myself are based in Israel, and I guess you've been hearing some of the news of what's happening here. So, we live in the Tel Aviv area, and luckily we're not directly affected, but still. Yeah, so I actually didn't want to spend too long on slides. I just wanted to give you guys a short introduction of who we are. We know some of the community a bit from interacting through the mailing lists and contributions and debugging NFS code over the past several years. So VAST Data. VAST Data is around 8 years old. My name is Alon Chorev. I'm a VP of Technology at VAST. I'm a co-founder of the company. And we built an NFS server, but it's just one part of what we did. We built a scale-out file system from scratch. We have our own NFS server stack that we built. We also have an SMB stack and an S3 stack, and we've been used today in various organizations out there. We built a very large, I would say, an architecture that enables building very large clusters, up to 100 or 200 or even 300 petabytes in a single namespace. And this is why we're often interested in high-performance NFS, and this is some of the things that we've been working on. What else is there to say? As I said, we're an Israeli company. We also have a branch in the US. We've been very active in the US. We've been active in, we have many customers around universities. It's pretty, I would say, colorful, and there's a wide spectrum of different types of customers. And that's it. And NFS is kind of I would say, the go-to protocol. It's the main protocol that we support and customers use today. We've been seeing interesting interactions, bringing NFS into HPC, for example, where many folks in the HPC industry were like, this is not supposed to work for HPC. We showed them that it actually could. And we actually want to be more involved and contribute more, because this is a pretty big part of what we're doing, and pretty big part of the success of the company is enabling this architecture to easily, integrate into customer environments by supporting a standard protocol and not inventing yet another parallel file system, driver, interface, etc.
Quick question.
Yeah.
Quick question. What versions do you support of NFS?
Both the V3 and V4.
V4 what? 1.0, 1.
That one.
That one.
Yeah.
Fair enough.
So if you guys have any kind of questions about this is the context of where we're coming from, and Dan has a few slides about some of the technical work we did around NFS. I'm happy to take any question you guys have.
Okay. Yeah. Start the slide. Share your screen. Can you share your screen? Or I know it's sometimes difficult.
Okay. I'll share the screen. A second. Okay. Okay, so the NFS stack in VAST Data. You see the screen?
Yes.
Yes.
Okay.
Yes.
Cool. Okay. So what is the VAST NFS client package that we're giving? It's actually a fork. It's a 3 external NFS stack fork. We started working on it in 2019, and when we discovered mainly 2 issues. We wanted to provide customers a working NFS RDMA setup for high performance, and when the customers installed Mellanox OFED, it disabled their RPC RDMA model, and we simply recompiled the same code that is in the kernel just to support their Mellanox OFED stack. And we also applied some bit of fixes to solve issues with RPC RDMA implementation. And that's it. That's how this work started. We saw naturally that maintaining third-party gun models is not easy. There's a lot of issues with that approach, and so we only try to give it to customers that really need performance from the system.
I would also, Dan, I would provide the context that on InfiniBand networks, TCP is very crappy. It basically uses interrupts on a single core. And when you look at the large HPC environments, and this is very true for the big national labs in the US and elsewhere for HPC environments, it's very much InfiniBand based. So NFSv4 RDMA is really the only option if you want to provide decent performance and latency in those kind of environments. So we just kind of had to revive this. I mean, the driver was working, but we had to enable it in environments that have InfiniBand, because if you have InfiniBand, you install the Mellanox drivers. Once you do that, you lose the NFSv4 RDMA support. So we kind of had to revive it for all those customers without intending to actually change the code. But then we also bumped into a couple of bugs that we fixed, that Dan fixed and contributed the fixes for.
Did you send those bit bugs? Did you send those bugs upstream?
Yeah.
Okay.
Which fork? I'll get to that. Okay. So in 2020, we realized that we also want to utilize NConnect and get more performance from having a larger bandwidth and more connections to our distributed cluster. And what we saw is that there was a limitation that we can have to provide a single IP address for NFS stream. So we did a bit of tweaks, and you also saw the patches because I sent them to the mailing list. And the first implementation, we took the transport layer, NetSunOPC, and backported only that layer to older kernels. So we had a few kernels working with an old NFS layer, but with a newer NetSunOPC, and it actually provided really good NFS RDMA support for these kernels. But it was really hard to maintain that because we saw that we had to maintain it for several kernel branches, which are quite old, and with a lot of cherry picking. Wasn't easy to do that, and we advanced later. Okay, so before I talk about what came later, I'll talk about NFS version 3 multipath. So the way this works is that we added two mount parameters. One is optional and controls local bind of the transport, whether it is RDMA or TCP, doesn't matter. And the second is more important, is the mode ports tells you the what are the target addresses. And the assumption is that you have clients that have multiple legs on the same subnet, and you have also our cluster that have multiple legs on the same subnet. And the idea is to make sure that all the ports on each side are used in a fully there's full use of the bandwidth for these ports. And we got really nice performance over these kind of setups using LDMA. And you see in the mount example, you provide NConnect 32, and it creates all the possible connections between each port in a full mesh. So the load is distributed quite evenly over the cluster.
I want to add some color to this. The reason why we decided to invent something called multipath is for we had a bunch of motivations. One of them is that, again, we work with large HPC customers, with customers doing AI, and those kind of environments were predominantly, using things like cluster and GPFS, which are very much built for performance. In order to saturate 100 gigabit, 200 gigabit, or 1600 gigabit, we've seen crazy things where, like a modern NVIDIA box with a bunch of GPUs has a bunch of cards on it. Each one is 200 gigabit. They wanted simplicity. They wanted a single mount point with just, infinite amount of performance. This is where it's coming from. We've been actually collaborating with NVIDIA on this. We've been doing the development, but we're collaborating with them in a sense that, they're bringing customers. We're giving them the driver, and this is where it started. Since then, we've seen hedge funds and any organization that just wants to give their application developers or researchers just lots of bandwidth. They've been excited to use it. The ability to use multiple ports on the source, in regular, in your default situation, if you have multiple ports, you're going to use bonding or teaming. You're going to combine them together to a single logical interface. Again, that doesn't exist in InfiniBand, and the concept is not new. It's called multi-rail in Lusterland. So again, you see there's a lot of analogies coming from the HPC world that we wanted to basically enable NFS to serve. So that it's just one more example. And we also have seen other effects where, given NFS by default, it has this one-to-one relationship between client and a server. If you have a very, very large cluster, like our NFS server can run across, say, 400 nodes, and we can see like 50,000 clients connecting to us. It's easier to also distribute the load with something like this. It's not very dynamic. There's no dynamic nature here of connecting across different connections, or there's no control plane that tells you which IPs to connect to. But basically, what we tell customers to do is they allocate a bunch of IPs to the cluster. We have an NFS server, a logical NFS server that's just distributed across many servers. It has a bunch of IPs, and each client just connects to some of those IPs. And this is how we build these very large NFS environments.
Local ports. That's not really ports; they're IP addresses.
Adapters.
Adapters, right?
Yeah.
Okay. And there's both ports are adapters, right? Okay.
Yeah, just ignore the word ports.
Right. Exactly.
Yeah.
I have a question about that mount command though. NConnect 32. Isn't that redundant with the full mesh? Why are you requiring the NConnect? What does it do with?
So I'll explain. We leveraged NConnect, which basically already had this, transport switch where you have something that holds a bunch of connections. We don't actually recommend customers to create as much of 32 connections, but between 4 and 8, it depends on how fast is your NIC. Is it 100 gig or 200 gig or using TCP or RDMA? But what customers would basically specify in remote ports could be a range of, say, 256 addresses that are distributed on the cluster side. And then each client would say, open 4 connections out of that range. How does he choose the specific 4? Currently, it's random. So So again, if you have enough clients and enough connections, you get a pretty random distribution. But it's not ideal. It's not perfect. It's better than say having something like DNS round robin, which would target you to a specific node, right? Like a single node. And I don't know, how many of this group is affiliated with, organizations like, Dell with Isilon or NetApp, but it's not different. Any one of those eventually has a cluster that has a bunch of IP addresses.
Yeah, we get it. So NConnect is being used as a limit, in other words. You could say NConnect 4 with 32 possible paths, and it'll just wind up with 4. Okay, got it.
Exactly.
And you're talking to two people that are working on that.
Right.
Exactly. So they're there.
Yeah. Okay, Dan, you want to move on to the next slide?
Yeah. Okay. So in 2022, decided to recreate the project a little differently, a big differently. We took the NFS stack from Linux 5.15 LTS, and we made it compile over, made it able to build that stack to target a lot more kernel versions, ranging from 4.12 to 5.19. And we also took patches and fixes into that stack, and all the LTS patches. And we also added a new capability, which is NFS version 4.1 multipath. And I will talk about that. So we allowed remote ports to work with NFS version 4.1. The difference is that multipath in that case is implemented at the NFS layer instead of SAMA PC. A single client behaves as multiple clients to the server. It has it retains the scalability that we wanted to have with the older approach, and it is working really well. And I'd like to talk a bit about the implementation, not going into many details because there's not much capacity to look at code right now. But I can answer questions about it.
So with 4.1, why do you need remote ports? You have session trunking.
We have session trunking, yeah, but we wanted to. Alon, I think you have a good answer about that.
We weren't. Maybe it was a gap in understanding, but we couldn't figure out whether session trunking actually meant that we could easily, through again the standard spec of the protocol, the server could tell the client to connect to many other servers.
Correct. Yes. So you can send a FS location to the server, which is going to return you the list of where this file system exists, and then the client can probe. Well, the client will probe all of those IPs for ability to session trunk, and then it'll create the trunk connections. So it will basically create all of those connections that you need, without needing the remote ports. It is a part of, I think it's from 5.18. It's in the kernel, but it relies that your server supports, session discovery, which is FS location query.
Okay, it's definitely something that we're gonna want to look into.
Yes, so while with V3 we couldn't provide the ability, there is no multipath in the protocol, but in V4 it naturally lands to having, to be able to do multipaths. So you don't need any, additional options that the standard upstream doesn't provide.
Mhm. One of the things that we stumbled upon is that given NFSv4 is stateful, we do not share state across the different nodes in the cluster of a single session. They, each one of them can serve the entirety of the file system, but the session state itself is not shared. So it's not that they're entirely equal, and you could serve the same, using the same session across those different clients in the same trunk. So I'm not entirely sure it was applicable to us, but given the discussion that we do want to have on how to get this done, if that's the only way, it could be a good enough reason to take that direction. So
yeah, we also wanted to preserve the way the customers that already received the driver used to specify and configure multipath. So they configured multipath in NFS3 using remote ports, and we wanted to preserve the same idea of configuration, which is the client knows how much it wants, like in terms of how many transports to open to how many other nodes.
Yeah, I
mean,
think
okay.
August's suggestion is a good one, in that if the server redirects the client, then you really don't need all the remote ports mesh. It'll simply connect to a new server using the existing NConnect value and create a number of new connections on which one session will be bound. Now, you, on the other hand, don't share sessions on the back end. So in order for the client to take full advantage of what she's describing, the application would have to reopen the file on each one of these new trunks. And that would get really, really awkward.
Is the session state not shared at all, or is it just shared just between a few nodes?
It's not shared at all, yeah.
I would say that we share the things that are say important for surviving things like failures, but what slot ID, NFSv4 slot ID is in use or not is not. So it's
Right.
like I would think that ephemeral session state is not, and the persistent session state is.
Got it. Okay, thanks.
So
Yes,
so
again.
each of your connections are then establishing a session of its own. So if you have remote ports, each that connection will create a session.
I have the next slide, which goes a bit more technical about that. Yeah.
So then you're basically on the client. You've also implemented then client ID trunking, because you're sharing.
Yeah.
For that
Yeah.
same mount point, you're sharing all the state for all of these sessions. So
Yeah.
right now the Linux client does not implement client ID trunking, but
Yeah,
basically
so-
in your customized version, you've added that ability. Okay.
Yeah, you can look at it this way. Yeah, each under this, with this patch, which I can share if you like. One superblock, one mount actually has completely separate NFS clients, and for each, and the idea is for each inode instantiation to pick one of them, and the client sticks to that inode until the inode is destroyed. And other changes that we had to do is pass a pointer to the right server, so that there won't be any accidental sharing of states between these two unrelated clients. So effectively, We have many clients. We have a single machine appearing with many clients. Of course, the client ID is client ID in that case was the client ID string was modified, so that they really do appear as multiple clients. And it worked, and it works well. We have customers that use it.
Right, but that's really not NFSv4 protocol.
Yeah, but it doesn't change the protocol, right?
Yeah.
They're sort of,
They just glom something onto the client.
yeah, they're pasting new behaviors on top of it. Yeah, so I think it's rather clever in a lot of ways, right? But, yeah.
So
I
what
mean,
we
there-
So what we try to do is basically be, as close to the protocol as possible. So we haven't, when you look at it from a server's perspective, like from the NFSv4 implementation, two servers don't even know that they're serving the same endpoint because we basically hash the inode and dispatch a different transport for different inodes. And we did basically the same for the v3 implementation. Again, we're not saying it's the best thing in the universe. I think we want to definitely study more about the FS location and referrals thing. When we were looking at PNFS a long time ago, we kind of felt that it solves the problem for data and not for metadata. Where still we wanted to scale metadata and data, which we do here is with this multipath implementation. So this is how we landed here, and I think the discussion we wanted to have is to get some feedback from you folks, like exactly like Olga said, like maybe there's something we missed in terms of the possibilities, and also if we want to contribute this, how does it coincide with the development of other things that are happening.
Well, so just jumping on the scaling of metadata. So the session trunking is exactly that. You can return multiple IPs of where things are, and then you're gonna spread across your metadata, right? And then PNFS would be separate. Your IO path could then send your IO totally to different a dedicated set of IPs, not even that have nothing to do with your metadata servers as well. So it's possible, you can do it that way.
Understood. And the session trunking opens a separate session per IP, or is that session does that assume that the server is basically like this multi-legged single server?
No, so session trunking is multiple network connections under the same session.
Mm-hmm.
So you basically sharing everything. You're sharing the lock state and session state across multiple IPs. Whether they're where they are located is up to you, right? It's on the same machine. If it's on the same machine, blah. But if it's on different machines, then you have to figure out how to share your state right across nodes, so to speak. Yes.
Yeah, but they don't want to. So, I mean, I don't think redirects, FS locations are going to solve their scale out problem, right? It can redirect the client to the so-called best server, but they have a large complex meshing back. There is no best server for this thing, right? The location, all the back end things can be accessed from any front end node. So,
Yeah.
Well, I guess where I'm going with that, how I was asking, Dan, whether or not, because they've posted patches and some ideas got in, other ideas basically said, no, we're not going to go, we don't think so. But whether or not they want to have their own custom, NFS Linux implementation is something that they need to decide. But if they don't, then it would be, I think this is the forum to figure out how to what does the Linux client currently misses, to accommodate, their needs, right? Or the needs of the customers that they're serving, right?
I think anything that involves new mount options is a tough sell. Especially when we have a protocol that should be able to allow you to do something like this, right?
Something that relies on what?
Oh, sorry. I said, I think anything that relies on new mount options is a tough sell. It's tough to want to merge something like that, because we have to.
Oh, come on,
yeah, but we can do it, but
we've added mount options. Yes, we don't like
sure,
to add
we do, but for something like this with that remote ports thing, I mean, I think that's a hard one. It's kind of clunky.
I don't think they're asking you to.
Oh, okay. I'm sorry, I misunderstood then.
No, so
right.
I think we're having the discussion that we wanted to have. We don't think what we have now is perfect for our customers. It's pretty rigid, like, specifying a range of like 200 IPs is not ideal. Sometimes often those clusters grow or shrink. Being able to hide that implementation layer and put that on some control plane would be perfect, right? But that's only possible when you're writing in your own, say, parallel file system, if you're like, a Lustre or GTFS or Weka. We wanted to have this kind of discussion to kind of understand, what's already there, what have we missed, what's going to be easier for you guys to perhaps consider, taking in. I think FS locations sounds like there's already a strong precedent that makes it possible for the server to tell the client, hey, here's a bunch of IPs. Perhaps, just putting it out there, we could also say those different IPs are not necessarily the same server, so you can session trunk on them, right? Again, I'm not entirely saying that we should. I'm not trying yet to convince you guys to support, client session trunking, but I'm just saying that I'm not necessarily adamant about adding a mount option where there's already a precedent within the protocol.
Sure.
That makes it possible to solve that specific part.
I do have a question though. I mean, what happens? So if you pick one client on the, and you stick with that per inode, right? What happens if you need to take that host down or the server down, right? Do you have to just reboot all the clients or something?
No. So the vast architecture, as I stated earlier, like we have these large clusters. We also have some small ones, but we started by solving a hard problem of building large clusters. So this is what the market was most excited about. And all those IP addresses are virtual IPs. So if a server fails, another server gets those IPs in less than 2 seconds.
So you float the IP to another server and then move the inode info there?
Yeah. I mean, I just to make it easier on you guys, like Isilon is the most similar thing that you're going to see out there in terms of an enterprise system, a bunch of servers, a bunch of nodes in the same cluster, sharing some state, but each server is eventually an NFS server. Virtual IPs can fail over between the nodes. There's a DNS load balancer that throws the clients around on the different NFS server. From that regard, it's pretty similar. The implementation is entirely different, but from that regard, it's pretty similar. I think one of the things I'm taking from Olga's comment is that, like, the combination of given we have we have control of the server, we could present different clients with different FS locations, therefore distributing them, right? Like a single client would still be limited from a metadata perspective onto a single server. It could open a bunch of connections in the same trunk, but again, from a metadata perspective, it would be limited. It may be good enough. I mean, we have seen customers do crazy things like get 1 million IOPS of metadata operations from a single server, and They managed to get it once they were using our multipath by connecting to a bunch of different servers. But I think data is the interesting part, and that gets resolved with NFS, which we don't support today because, again, we just went ahead and did multipath to kind of achieve the same goal. And I still feel there are some inherent trade-offs, but I feel this is one option that we do need to consider, basically.
But correct me if I'm wrong, though. FS locations isn't like per inode, right? It's per.
No, it's per file system.
It's per file.
It's per file
Okay,
system. Yes.
Yeah. So if you're splitting your inodes onto multiple hosts like that, I'm not sure how much that helps.
Right.
The PNFS is right. Yeah.
So I'm interested in, like, figuring out if you guys, have the need for client ID trunking, and trying to add that to the Linux client, because I think that is interesting. That is, something that, even NetApp, has been kind of, asking. But, our maintainer, who's one of the maintainers who isn't there, unfortunately, to comment, has been very against client ID trunking, basically saying that there are no cluster, real cluster NFS servers out there, right? And that's why, that whatever you need is basically that the current implementation handles. And I'm not of that opinion, but but having others also advocate for needing such functionality, I think would be might be useful. And then see how you guys, what exactly that you're proposing to do, to accomplish the the client ID trunking. Would be interesting.
If I can inject here, it sounds like you're looking for allowing I/O for each file to go over perhaps a different connection. That PNFS is the right answer, and we already have several PNFS layout types that do exactly what you need. And the one that is probably closest is either the file layout or the flex file layout. And in that way, the NDS can hand to the server a layout for each file, and the MDS can control where that client does the I/O for that file. So it can go to multiple servers, it can go to one, it could be mirrored. I think that's the right answer. That's the protocol. That's the one that lines up, I think, with where the protocol has gone.
Understood.
And we support that today. We support that today. So you could, if you go there, you've got a client out of the box.
And just out of curiosity, do you folks see any like significant performance trade-offs? Like the fact, does it add like another RPC call for every time you open a file? Does suddenly small file workloads like Git workflows, do they become inherently slower, or it's completely transparent and there's no complaints there?
I can't say.
Can we do a layout?
So like for file layouts, for instance, you have MDS controls whether or not you want to do PNFS. So there's a certain threshold, so if your file sizes are smaller than this, then we do know that there is no, that you will lose, if you had to actually go to a different DS, establish, a client ID in a session, and then, do your, 10 bytes IO. It's definitely worse than just going and getting those 10 bytes from the MDS. So yes, so the protocol has this where, where you say what your threshold is, for, and I don't remember if it's, per server, per file, I don't remember those details, but yes, you can control that so that your, particular workloads suffer, right?
Mhm.
This session creation is only once you talk to the yes, then it stays. You don't destroy the session. And depending on how your layout is given, so you can say return and close. So, or you just give it a layout and then client can use it later on, so he knows where the file is. So it discovers the location for this file only once.
Got it.
Yes, but that's if you're rereading, reusing the file, right? But if you say workload is just open once, but a bunch of small files, you don't want to pay the
now
cost.
we have this. This is
of-
single component. So layout, get, and the open is a single component. So technically, you don't have another round trip as soon as you get the layout, and if you have already established the connection to data server, so then it's for free as well.
Sure.
Yeah, it's only bad if you have as well million of data servers and your each file on different data server, then you are really unlucky. But
So I was wondering, I'm not a Linux guy, but in your current system, it sounds like you have separate client IDs for the various servers in your cluster. And what happens if it has to do a recovery on one, but not the others? If you're handing them out per inode, that would be isn't that pretty confusing? I'm wondering about fault tolerance and reliability here.
Mhm. So, what happens when say a server goes down, and a client is forced to reconnect one of the sessions that was connected to that specific server. Let's say I'm connected to a bunch of different servers with a bunch of different sessions, and only one of them went down, which is, for example, what's happening when we do an upgrade. We do a non-disruptive upgrade where we upgrade the nodes one by one. Then, the virtual IP would move to another node. A TCP connection would be recreated, and the server would basically force like a session reestablishment, which would be transparent to the application.
Okay, but that's the session. Does the client ID still work? In other words, is it just a create session on the new node, or does it have to do an exchange ID, etc., followed by opens with reclaim?
So I'm not sure, Dan. I think the client ID can be reused, but I'm not sure.
I think it is reused. So I think recovery isn't very different under this mode that we created.
I just mention it in part because Amazon's EFS does that. Every time you make a new TCP connection to their cluster world, you sometimes get a different cluster, and then it's like the server has just rebooted. You have to do an exchange ID, create session, recover all the opens using open reclaims, etc. It works, but the recovery code in the client has to get it right. And when we first did it, I'm a FreeBSD guy. We found a number of bugs in the client code.
So Olga, beyond what we mentioned about scalability of metadata across more than a single machine, what other motivations you felt that you've seen for client ID trunking?
Well, it's your basic premise. You don't want to share state information across across your servers. So, so you want them to work independently. Yes, they do share. They will share some information, and I think NetApp wanted to share. They didn't want to share state, but they wanted to share. But they do share locking information. So the open and the locks. So, but the session is not shared between nodes.
Yeah, so it's exactly the same with us, and I wouldn't be surprised, right? Like the ephemeral session state is changes very, very often. It's almost like sharing the state of a TCP connection, right? Like you don't want to share something like that across servers. It doesn't make sense, but things that need to survive a server failure are the ones that have to be persistent, which is locks and open and persistent file handles.
Right. But, you know, so far we haven't been, you know, successful in saying that, yes, client ID trunking would be something that we can put in.
Understood. I think that I think we have, you know, we have before we go to advocacy and building a case for that, I do want to do, we do need to do some more homework and build a case, and alongside that we could add some, you know, I would say like you know, reviews and comments from some of our customers that are also active in the Linux community.
So I wanted to ask about RDMA and multiple connections. So when we were putting NConnect and then looking into, so right now the Linux client limits it to TCP. And I believe at the time, even though Chuck, I think is, I'm not sure if he's, it says that it's true or not, but I think he tested NConnect with our RDMA and found no additional performance. Is that, am I speaking correctly?
You are speaking correctly, but I found that while testing with one NIC.
Okay, so the case is then for multiple NICs would be so, or maybe a NIC with a dual port, right? I mean, so basically more than one port. Is that one we're assuming that we're going to see performance benefits to and I think whether this is NConnect or multipath is probably similar, right? So what's your experience with that? You know,
yeah,
since you are saying that, you know, 200 gigs, you know, NICs, but you know, I was assuming that even with a 200 gig NIC, you know, a single connection should do pretty well.
So it's really multipath that you know makes enables, you know, basically infinite bandwidth, right? So getting to what VAST usually does, you know, even today, I would say the default, you know, the go-to servers that we provide customers today are 100 gigabit. And then again, you know, some of those customers would buy those bleeding edge 200 gig, 400 gig capable servers. And then thanks to the combination of multipath and RDMA enables them to saturate their clients with this. I think the other point about using multiple local interfaces is important, and I'd like to share like a bit more color of the things that we've been doing with NVIDIA. One of the things they were excited about is, you know, they have these very large machines, multiple NUMA domains, multiple NICs, and being able to use a single mount point without thinking about anything is very comfortable for them. And we got to the point where, you know, an IO is dispatched by the driver. It would send the request from a connection that's sitting on the same NUMA node as the GPU that was dispatching that request. And it would also leverage something called GPU Direct that enables the RDMA transfer to go straight from the network interface card to the GPU memory without going through CPU memory. That's another patch that NVIDIA actually did to RPC RDMA, which is just leveraging some of those internal interfaces to be able to do this kind of, you know, understanding what NUMA node you're located in, and also do memory translation in order to bypass the CPU memory.
But that's only a part of their MoFed, right? It's not upstream.
Correct. This
So
part is
you-
part of MoFed because again, it's used by like I think it's possible because they're exposing some interfaces that are NVIDIA specific. But it's just for us. It's just one example of somebody wanting to use multiple interfaces on the client, right? And I'm curious whether
yeah.
it's something that we could also achieve using FS locations. I don't see that.
But with RDMA, I mean the session trunking is transport layer independent. It'll work for TCP as well as RDMA.
Yeah, so I'm referring specifically to being able to basically create connections from. We're talking about session trunking and NConnect, but one of the things that we do is we are able to tell, using those mount options that Dan just showed, we're able to tell the NFS client to open different connections from different source IPs, basically. In this example, it's for
so we don't use source port binding because we assume that the network layer is gonna route the things appropriately, right? So which which I guess is I'm not a network person, so I might be saying something silly right now, but if you have two interfaces and they naturally live on two different subnets, then your network layer is going to route things to the appropriate interface, and therefore port on the NIC, right? And you'll have two independent paths, so you don't need to do any kind of source port binding. My only lack of network understanding is that if you're somehow if your interfaces have IPs on the same subnet, then I'm not sure how
and we
how you can do the routing. That's where you need to bind your sockets to the appropriate interfaces so that they don't go, because the route is typically for and
the reason
per subnet.
So I would say that the reason that we use the same subnet is to achieve failover. So what we can actually showcase, and we can even show it to you guys, is we create a mount point. It creates a bunch of connections. It splits them across two ports, and then we plug out a single cable, and all the connections get recreated. The sessions get reconnected on the second port. And again, in HPC world, this is standard. This is multi-rail. This is what happens when you want a file system that's highly available across more than a single interface. And that can't be done if you're using two different subnets. And it gets even more complicated when there's routing and the client and the server are not in the same subnet. But I think we went like through a rabbit hole. I think that, again, we want to do some homework, and perhaps we can write like a proposal of what we think we can leverage from the things that we learned about, what we think we can't, and what do we propose to collaborate, with you, with the upstream community, in order to perhaps be accepted. And we basically went through client ID trunking. We talked about using two or more local interfaces. I'm curious, I know that NFSv4 is the one that's seeing a lot of traction. We actually have lots of customers using NFSv successfully, and I'm very much aware of some of the differences and some of the drawbacks of using NFSv3, but it's still very much out there. I'm curious whether it's even, let's say we wanted to add, we wanted to contribute the multipath implementation for NFSv3, which basically, allows propagating a parameter saying, let's open multiple connections, not to a single port, but to a range of ports. Is given the fact it's NFSv3, it's out of the question. You don't want to talk about it even, consider it, or those two versions are living independently in your minds?
I think we might have skipped over something important. We've got a SysFS mechanism for controlling connections between clients and servers, and we designed that in lieu of providing mount options like local ports and remote ports. Why can't we talk about using that facility for managing the connections between the clients and servers rather than a static configuration like this mount option arrangement?
So the reason
another reason we also did this because someday we might have some sort of orchestration protocol that's actually running in a daemon, and it can actually poke the updated let's call it routing information or mesh, let's say mesh information into the client kernel so that it can tear down connections that are no good anymore and establish connections that are going to be known to be good, at least in the recent past. I think that's the mechanism that we prefer to use rather than a local ports, remote ports a mount option thing. Now, with regards to your V3 thing, I think the issue with V3 is, if we're doing this at the RPC layer, I think V3 can be supported. The issue with V3 is that is a more of a protocol, and we can't really make changes to it, and it's challenging to make changes to the implementation if the protocol, if we run into issues with the protocol. With V4, it's a little easier to get help from standards bodies to make adjustments as needed. So that's sort of the resistance to talking about V3. If you present a proposal that amplifies V3 in some way, as long as it's an implementation change that doesn't impact interoperability with existing implementations, non-Linux implementations, I think that's something that could be considered.
Okay, thank you. I would just comment that we went with the mount options. Because at the time I don't think we knew or we don't.
Yeah, it's new.
Perhaps
It's very different.
CTL, right? Is that the one you're referring to? And I think I've seen like an example using RPC CTL as a command line tool.
That's it.
Yeah.
So I think it's from a design perspective, it's a good direction, definitely. It's much more flexible, and then it enables doing things more dynamically.
Yes.
The challenge that we have is that again, we chose the path of going with standards, and some of those standards are other layers above the stack, above NFS. So let's say I have a customer using Kubernetes, and Kubernetes has native NFS support. We can actually propagate those mount options, but we can't have Kubernetes leverage this new kind of mechanism because it's just new and different. And same goes to FSTab and many other things that our customers are just kind of used to.
You can have Kubernetes can run a script.
The Kubernetes can run a script, and the mount options aren't part of the protocol. They're not part of the standard. So I don't understand that argument.
Yeah. This is that's the client side implementation. So
yeah, and
so
we can tell them to do whatever they want, whatever we want them to do.
And quite frankly, probably the NFS provider in Kubernetes is probably going to want to wire in these SysFS interfaces at some point, because more and more controls are going to end up under there, and that's these sort of orchestration places are where we expect this kind of stuff to be used.
So going back to the SysFS interface and managing transports, what I found challenging was the fact that you're the transport layer, and you supposedly probably shouldn't be worrying about the upper layer, the protocol on top of it. But we do need to worry about the protocol on top of it because, for instance, we shouldn't be. So there was a talk about, let's say, adding, a transport connection using SysFS. Not, but when you add something, for V3, it doesn't matter. A connection to a server is a connection to a server. It's V3, but with V4, you need to make sure. So like you can't add it to an existing RPC client, that is connected to, an NFS client. We need to know that it actually belongs to the same server that the RPC NFS client expects. So
You
there
have to trigger trunking discovery.
you have to trigger what?
You have to trigger trunking discovery on the new connection.
Right. Yes, exactly. Or I would call it identity discovery, right? And so that's a piece that has that I think is still missing from SysFS, managing managing the connections. So I mean, we added this hack of you can change your destination server IP of destination IP of a connection. But what's missing is that, yes, if you do change it for something like a V4, we have no verification that that belongs to the same server, and that really needs to be added, for it to be robust, right? Otherwise, you could mess things up.
Just don't do that thing.
Yeah.
Yeah, I mean, the other
Sounds
thing
like
is,
just-
yes. So if you're messing with
when I
your
do this. Don't do that, right?
right,
Because
there could be an argument,
you know.
administrator needs to know what the heck they're doing, so if they're adding, messing with connections, they, better make sure that it's, it's what they really wanted to do. But
I think that could be bundled in a user space tool pretty simply. I
Yeah.
agree that is a missing piece, but it's not rocket science.
correct, but in order to make it a little bit more stable, and then I think if we have that, then there would be more. Then I think adding multipath for V3 through SysFS, would be more acceptable. Because we know that it's not gonna mess up V4, or that V4 would work, and V3 would work. So I think. Yes, so adding multipath through the SysFS interface is possible. I'm with you. I love mount options. I would rather use mount options than SysFS. Because
The problem is we can't change the values of local ports and remote ports without a remount, and that's fraud.
I don't know about that.
what do you mean? Say that again. We can't.
You have to change the settings on a mount option. You need a -0 remount, or you need to unmount and remount and mount.
Sure.
Historically you did, but now
Yes.
you can do an FS configure.
Okay.
Yeah, so we could theoretically do this. It's not wired in today, but it could be done.
I just like the idea of having the ability to dynamically change these things without perturbing the existing mount.
Right, but
What
so let's say.
Why do we need?
So
That's
let's say
extra
we can right now do multipath with V3. So what you do is you do mount, and you do nconnect 16, and then you go into your SysFS, and then you change your destination IPs to whichever ones you wanted it.
Right.
And
already have
boom,
this, yeah.
Yep.
Exactly.
and boom,
Exactly, yeah.
right? So great, but it's an additional, so like it's an additional step, right? I mean, it's not accomplished through just doing a mount. So then, somebody, if they really wanted this multipath thing, they would have like a script, right? Let's say, over a mount, which would do mount, and then it would, take some options to then go into SysFS and script out changing the ports, changing the destination IP. So it's more complicated than having a mount option that said, you know,
It is, but
remote.
it has to be dynamic, you know, those IP addresses, can change. The path between clients and servers can change, but the mount has to stay where it is. So it's actually dynamic information.
So
You know,
it could be,
same-
I think it could be both, you know, I think it would be useful to have
Right.
it, you know, in the beginning
Maybe.
to be,
Yeah.
to be able to do it. And then as if you need to change it, then you do, you know, because you can't predict that. And then you change it, you know, via SysFS. Anyway, so, but I know,
You know, you
no,
have to
no
convince,
new
right?
mount options.
You know, you have to convince, right?
But by the way, regarding multiple mounts, how can you tell with, suppose you did several mounts to different servers altogether, how can you tell which RPC client belongs to each of these mount points? Did we add
There's a very new addition to SysFS that'll symlink the mount point. It'll add SysFS tree per mount point, and it'll link to the transport layer. I
okay,
think that's a 6.6.
very new. Okay.
So is this your new Ben, you know, the NFS, SysFS stuff?
Yeah,
Is that from your?
Yeah, that'll be under SysFS, FS, NFS. And it'll create symlinks to the transport.
Okay. Yeah, I think, Olga, what you suggested about like enabling both ways, you know, from an engineering perspective, we like that there's one way and one good way to do something. But I feel that if the only way we can do that is through, you know, a sequence of commands, we're going to end up, you know, perhaps wanting to contribute something to NFS utils that's going to parse the etc NFS mount con files, and then perhaps it's going to find that information there, and it's then going to run a sequence of commands, and if that fails in the middle, you have like a mount that's somewhere midway configured. So I do feel that there's some elegance in also being able to, you know, to pass that information when you execute the mount command. I feel that we definitely want to get to the point where things are more dynamic. I mean, even if you look at the fact that when you mount using DNS, there's a DNS resolution once throughout the lifetime of the mount point, and that's very painful for clusters, because one of the ways us enterprise NFS vendors we load balance is based on, you know, DNS, and when at the time the client is doing a DNS lookup, it could be, you know, 600 days and since then, you know, so often have the load changed and redistributed across the cluster. So I'm all in favor in doing things more dynamic, but we are also in this position where we want to expose this functionality, and I feel there's and you know, I also accept the suggestion of working with the Kubernetes community as well, and you know, opening up those interfaces there. I just feel it's a process that takes a long time.
Well, but I guess the answer is no mount. I mean, no mount options. So yeah, SysFS is the way to go. But I'm just saying, I personally like mount options. So.
But doesn't migration solve this kind of problem? So because server at any point, at least for version 4.1, can always says, okay, now this everything moved to a different place.
As long as your server is actually up to do that.
Okay, and
So
then
if
you
your
have
server is
multipath.
migrating, then it needs to say, okay, I'm still here, but I'm not serving data, you know, go somewhere else, right? But what happens if you are actually, you know, your server went kaboom?
Right. So then you need the multipath there in the first place. That's right.
And you want that name to resolve to something else, right? So I think one of the reasons we added this ability to change the destination IP is for cloud VMs where your server, got spun up on this VM and then it crashed, right? And so it gets spun up on a totally different IP, but the client basically like now doesn't know, okay, my server's down, it'll never recover, right? So, but you needed a way to point it, we know that the server is up, but just elsewhere. So we needed to point it to a different IP, and we know it's the same server, so through SysFS, you can redirect it to a different IP. So not great, but kind of solves your DNS, resolution to go elsewhere.
Understood. I'm very curious what is achievable using FS locations, because I feel, you said this happens once for the lifetime of the mount point.
It's per file system.
Okay.
So once you
It's an
cross a file,
attribute.
well, no.
It's a get out or
So sorry about we're talking about session trunking discovery, right?
Yeah, because I
And-
feel that could be
and-
another place where
Yes.
things could be more dynamic.
So what's currently there is just done once. It's once you discover a file system, you ask, okay, where it is located. What's missing currently, and which I'm supposed to be working on at some point, is having an ability to rediscover your trunking group, right? Trunking ability, because things could have been added that you're now missing. So if things leave, we handle that, because typically if something goes away, it gives an error, and like BAT session, I know nothing about you, and you can shrink your trunking group, but there is no rediscovery currently, and that is something that we need to add to, I guess it should be policy based, so let's say, every X number of minutes, you're gonna go and you're gonna ask the server, hey, what's the trunking group membership now? And then
Okay.
do that.
So I just want to point out that we've discussed, two different mechanisms. One of them is, a smart cluster that thanks to something like client ID trunking, the client could talk to multiple servers. And now we're talking about something that happens on the client side, which enables it to add and remove transports. And the use cases that one of the use cases that you're talking about is, say, a failover. And I feel that those two things, like, it would be very cool if a server implementation, in order to make it very simple for the clients, could tell it, hey, there's rediscovery. Just know that there's now another IP that you can connect to. And then, if you want to do a migration of an NFS server in the cloud, you can just gradually have the client, reconnect to another server and eventually shut down the old server. Because what we're describing here, by exposing those SysFS interfaces, there's now, I would call it extra responsibility of building this orchestration that's running on the client, where many vendors are building those servers that are becoming smarter and smarter as time goes on, trying to put as little state as possible and little knowledge as possible on the clients, right? Like that VM that wants to connect to another NFS server, it doesn't have a control plane for NFS, right? Like somebody needs to bring that information saying, hey, that server moved to a different IP. And if we could somehow put that in band in the protocol, it could be more seamless. So I think, again, that could go into kind of that proposal saying, hey, client ID trunking could be interesting along with rediscovery.
So what I'm hearing is some protocol amendments, right? So they're always welcomed, right? 4.2 is extensible. We don't need to change the version if we want to introduce a new,
Although this isn't exactly the group that you want to talk to for that.
sure. Well,
I mean, we know what to do, but we're not the head MFs in charge.
well, but we can say whether or not this is crazy or not, right? Whether we're gonna implement
something
it.
like something like a session flag that you get from the server that says, "Hey, we've got some new stuff," that it advertises on one reply to a sequence or something. It'd be probably reasonably efficient. If that's what you're looking at.
Question, it's a different question. When is BAS going to be coming to one of these events so we can
Maybe.
hit your server? Start hitting your server. Is that something that you guys would be willing to do? I mean,
Well,
it's
most
something
people
that
you
you
just want
can
to
do
help.
remotely. We have it, or you can, we usually have it in the spring or fall.
Session flag.
So we're looking for larger. Sorry.
Yeah, I'm sorry, I can't hear you.
Yes, sir.
My apologies.
When was BAS going to come to one of these events so we can start testing against your server? That's the question. I mean, and we'll have another, in theory, have another one in the spring, and we'll have a remote access like we do here. And then we have in the fall, which will again, we have, we understand the travel budgets are tight. But this is something that we really need. You really need to come here so we can test against you guys.
So,
Well,
Something that
so first of all, we would be happy to be there with you. It's just been Dan and myself just didn't the schedule didn't add up, and
fair enough.
frankly, this is the first time I've been to an event like this. I wanted to join some more sessions, and I didn't necessarily know what to expect. We wanted to be better citizens and share what we did and understand how to collaborate. So I completely I take the invitation completely. And we do have a few large labs of our own where we do things like hosted POCs for our customers, and we can definitely open remote access to anyone for testing.
Cool. Perfect. That's perfect. That was the right answer. So if you're in the future, which is fine. Yeah, exactly. It's but this is something that I think this is the reason this event exists. This guys that a company like you guys. So we can pound on it. You get your latest and greatest fix, and we pound it, from all different vendors. So hopefully in springtime, you're on the list. So you'll be getting emails, not so much so you don't have to follow the list. We'll make sure that you get. I will make sure you get the email. But so just plan on just coming. Even in face to face is great, but at least remote.
Yeah, thank you.
In the future. So, and you're more than welcome. Thank you for coming. So
Thanks a lot, guys. It's great.
Yeah,
So-
that is very fun. Yeah.
So I have a question
so-
about testing. So you've discussed, what you currently have is that you provide customers with a custom kernel that has all of your changes.
I gotta get at it.
So Steve, that's kind of hard to test, right?
Yeah.
We need the custom kernel. But my question is, what happens if just an upstream, whatever, like a RHEL kernel talks to your server? Does that work? What kind is it? It'll work, but just gonna have limited, functionality.
So 90, I would say 90% of the clients talking to BAS are standard vanilla NFS clients, right?
Okay.
It's really 10% are the ones that need NFS over RDMA with their MoFed, or that they need multipath. It's like the majority just don't need those things, and then it just works for them. let's say when Pixar renders their movies, those guys would never take a driver from us. But they're very excited about VAST, and they're using it at a very large scale. And this is how it looks like. We find those, those big ones, and some of them are very adamant about not taking drivers from anyone. What we do have for the customers that want it, I'm going to share my screen for a second. I'm going to show off some of the things that Dan did. Can you see my screen? So
It's
this
coming.
is. Can you see
Yes.
it now?
Yes.
Okay, so this is like publicly available, vastnfs.vastdata.com, and we basically have an entire user guide of, what kernels do we support, how to install it on RHEL, on Ubuntu, how to config multipath. There's some stuff around routing tables here. Mount parameters, all the things you've seen are documented here. I'm going to send a link, and it doesn't require a custom kernel. It requires downloading the source and rebuilding basically a bunch of drivers, like RPC, RDMA, and the NFS driver. I'm also going to show off a little bit saying that Dan has added lots of trace events that I don't know if you guys would be interested in taking. I think, Dan, we should definitely try and send a patch, because when we are able to debug a client in funky situations, and we just missed a bunch of lots of events, and
How did we lose them?
and present and also read them in colorful ways. These are things that Dan would be happy to demo, but it's another thing that we did in the area. I'm going to attach a link for that.
Yeah,
Folks
we
might
are
also be
always.
interested in becoming a partner with Red Hat, because we do something called kernel ABI symbol stabilizing. I'm not sure if you're familiar with that for partners.
I'm not.
I mean, basically, for partners that want to either add third-party modules or recompile modules, we work with them to stabilize the symbols in the Linux kernel, which is exactly what you're doing. But without a partnership, you end up having to discover which versions of RHEL kernels will work with your SunRPC, with your modules.
Understood. I do remember attending meetings with the Red Hat folks. I think we were introduced by folks at LANL and LLNL, which we are working very closely with. I don't know if we kicked off a formal partnership, so this I'm happy to facilitate that.
Cool. Thanks a lot, guys. I'm gonna have to go.
Yeah.
Yep. Thanks.
Yeah, I still have the recording going if there's any further discussion that we want to catch. I understand that things got a little crazy with discussion, and maybe Dan has more he wants to present that. But we have some folks that have our time limited that have to leave here.
Yeah, I can answer more technical questions about the software stack. I mean, if you want, it was very complicated to make the NFS stack from Linux 5.15 compile against a lot of different versions of the kernel. So we use a technique that's called compat checks, like a configure script. We have an open source project to check the features of the source code to see what APIs are available there. And then we use the compatibility layer so that we didn't have to change a lot of the code base to deal with all the different APIs of the different versions of the kernel. So that's something that Mellanox also did with their stack, with their MOFED. And And we are going to have to. It's hard to maintain it, and I see that we're going to have to do the same thing for a much later version, because now we have 6.6 and it's quite ahead from 5.15, and say we want to install our stack on Ubuntu, the newer version of Ubuntu. It has a much newer kernel, and then it won't work. So it's a challenge.
That's why, it's better use vanilla, and basically try and get all of, your changes upstream, right?
Exactly.
And
That's right.
and and that's why, talking to like folks around here, try to figure out. Yeah, so I think the Linux kernel typically doesn't want to take anything which is very narrow customer or range specific, right? But if it solves a generic problem, so it's not very like vendor specific, right? Then this is definitely what we like to see, because that it improved the overall NFS support in general, and I think that's a good thing. So, but we definitely have some very strict. We have some opinionated people, who want things done one way or another. So unfortunately, but but in order to go around needing to build for this version and that version, this distro would be. Ben, why are you typing instead of talking?
Because I
Because
was listening to you.
Okay.
Yeah, I mean, we are investing in this path even, and while we know it's we could have saved Dan's and other people's time to do other things, but it's an insurance policy, right? Like, starting off as a new company, initially we had to move fast, and we have customers that are using it in crazy scale today. So we did what we have to do, and we're now going to start and see whether we can get at least at some point to the point where we can shut it down when everything is upstream. But
yeah, I for instance really want NVIDIA to freaking stop overriding the Sun RPC RDMA modules, and port their stuff upstream.
I got them to stop. I mean, they didn't do it across all the different distributions that you install Mofet on. But if you're going to look at the Mofet install script, you're going to see that they have a whitelist of kernels and distributions that they now support. And this is because we had. I made like 30 of our customers reach out to them and say, we want the vast NFS over RDMA. And I told them, hey guys, I'm getting NFS over RDMA working in environments that you never imagined it's going to be working. It's running even on Ethernet, on Rocky, with many of our customers. So they got very excited, and they started whitelisting different distributions, and it even started 2 years ago. So,
but now we need to get your changes into into upstream, because you're also modifying, putting stuff on top of
I have a nickname for our NFS stack. It's like the it's the OFID of NFS. Like you have you replace.
Not a good parallel.
Yeah, but that's what happens. A customer installs Mellanox OFID, and then install VAST NFS, and then they get everything. Like they get the newer, they get the new InfiniBand stack with the new NFS stack if they have a very old kernel. And it's crazy to support that, because they have third-party models that depend on third-party models, like 40.
Kind of being from a lab which runs big HPC clusters, I guess our admins will never install something which is not coming with the Linux distro. I think the HPC people are very, very conservative, so you cannot convince them to run something else. And this is as well kind of, if you get it in upstream, then it's probability that there will be more use, it's higher.
Yeah.
Indeed. Sounds good. Well, I
Okay.
also have to run. Thank you very much. Yeah, I think hopefully it was useful for you guys as well.
It was very much.
Yes.
Thank you, and thanks for your time and collaboration.
Yeah. Thank you very much.
Thank you. And stay safe.
Thank you very much.
Yeah,
you.
stay safe. Yes,
Yes, love and support.
support.
Bye bye.